So today I want to share some information about consensus mechanisms in blockchain technology. A consensus mechanism is a protocol that is used to achieve agreement in the state of a distributed ledger in the blockchain network. And the consensus mechanism is a key component of a blockchain system as it enables all participants to agree on the current state of the ledger, ensuring that the accurate and tamper-proof. But why is such a mechanism needed? A consensus mechanism is needed in the blockchain network to ensure that the participants have consistent view of the current state of the ledger without any discrepancies. Otherwise, it would be difficult to prevent conflicting transactions from being added to the blockchain, leading to errors and inconsistencies. And a blockchain is, as you know, a distributed system, which means that copies of the ledger are stored on multiple computers called nodes. And because of this, different nodes may have slightly different version of the ledger, which can lead to conflicts. And this may create or ensure, we need to ensure the right version. And such consensus mechanism is necessary to ensure that to function, even when some of the nodes in the network are unreliable or are trying to cheat. And this is achieved by making it very hard for malicious node to take control of the network or cheat, because a malicious node will not be able to gain support from the other honest nodes. So essentially, the consensus mechanism is a key component of blockchain system that enables all participants to agree on the current state of the ledger and ensures its integrity, security, and reliability in a decentralized manner. There are several types of consensus mechanisms that are used in blockchain networks: proof of work, proof of stake, delegated proof of stake, practical Byzantine fault tolerance, and Raft and Paxos. Each of these consensus mechanisms have their own advantages and limitations and are suitable for different use cases depending on level of security and scalability that is required. Now, what's proof of work? It's a consensus mechanism used in the blockchain network to achieve agreement on the state of the ledger. And the participants, called miners, use their computing power to solve complex mathematical problem. And the first miner to solve the problem is able to add the next block to the chain and is rewarded with the cryptocurrency. Now, here's an example of how the proof of work consensus mechanism might work in a simple blockchain network. For example, there are multiple miners connected to the network, each with their own computer. A new transaction is added to the network, and the miners must now compete to add the next block to the blockchain. Now, to add a new block, a miner must solve a complex mathematical problem called a hash puzzle that requires significant amount of computational power. Now, each miner uses their computer to repeatedly calculate a cryptographic hash function, trying to find a specific output value that meets that criteria. For example, the value must start with a certain number of zeros. And when a miner finds the solution, they broadcast it to the network, and other miners verify that solution if it is correct. And once that solution is verified, the miner who found it gets to add the block to the chain and is rewarded with the cryptocurrency, for example, Bitcoin. And this process is repeated for the next block, and the new block contains reference to the previous block, creating a chain. And this process is called mining, and it secures the network by making it computationally expensive for any attacker to control more than 50% of the network. And this is a simplified example of how proof of work works in practice, and how it's implemented can be complex and the performance may vary between different implementations. Now, proof of work is currently the most used mechanism for securing public blockchains. It comes with a high energy cost, heavy computational requirements. What's proof of stake? It's a consensus mechanism used in the blockchain network to achieve agreement on the state of the ledger. And unlike proof of work, which relies on miners solving complex mathematical problems to add new blocks to the chain, in proof of stake, validators are chosen to add new blocks based on the number of tokens they hold in the network, also known as their stake. For example, here is how it works in a simple blockchain network. Say there are 100 tokens in the network and 4 participants, A, B, C, and D, each have 25 tokens. And a new transaction is added to the network. And the participants must now agree the order in which the transactions will be added to the blockchain. In proof of stake, instead of using a computational power to add new blocks, the system selects the validator for the next block proportional to their stake. So in this case, the probability of the validator being chosen is proportional to the number of tokens they hold. A, B, C, and D each have the same number of tokens and thus have equal chance of being chosen as the validator. Now let's say A is chosen to add the new block to the blockchain. She is responsible for validating the transaction in the block and adding it to the blockchain. And in order to complete this, she may be compensated or rewarded. And this is a transaction fee or newly minted coin. And this process is repeated for the next block. And the probability of validators being chosen will be updated based on their current stake. And because the validator is chosen based on the number of tokens they hold, validating a block becomes less expensive. No large investments in specialized hardware or high electric bills are needed. This is a simplified example of how proof of stake works in practice, but the actual mechanism and the details could be actually complicated and could vary as well. Now, what's proof of burn? That's a consensus mechanism used in blockchain network as an alternative proof of work and proof of stake. In proof of burn, miner burns a specific amount of cryptocurrency, sending it to an unsuspendable address, thus proving that they have vested interest in the network's success. Now, here is an example of how proof of burn might work in a simple scenario. There may be multiple miners connected to the network, and the network uses a specific cryptocurrency as a token. A new block needs to be added to the blockchain, and the miners now compete to do so. And to participate in the competition, a miner must burn a specific amount of cryptocurrency, say 100 tokens, and this is done by sending the tokens to an address also called a black hole address, where they can never be spent or recovered. And that miner then sends the most tokens to the black hole. That miner is chosen as the next block producer. Once the miner is chosen, they are responsible for validating the transactions in the blockchain and adding it to the blockchain. The miner is not compensated with newly minted cryptocurrency as in proof of work, but they can expect some kind of a mining reward of transaction fees. And this process is repeated for the next block, and the miner who sent the most tokens to the black hole address will have a higher chance of being selected as the next block producer. And because the miner is required to burn their tokens, they have a strong incentive to act in the best interest of the network, as the burn tokens can never be recovered and the miner will less likely be malicious. And this is obviously a simplified scenario of how proof of burn works. but actual mechanisms are obviously more complicated, and the performance may vary between different implementations. Now, proof of burn is not a widely used mechanism and it's only used for few projects. Proof of work and proof of stake are more popular. It's difficult to say which consensus mechanism is the best, as the choice of mechanism will depend on the specific requirements of the blockchain network, and each consensus mechanism has its own advantages and limitations and is suitable for different use cases depending on the level of security, scalability. Proof of work is currently the most widely used mechanism, and it's also has been used successfully to secure Bitcoin and other networks, and it's considered to be very secure and makes it computationally expensive for attacker to control more than 50% of the network. However, a proof of work is very energy intensive, as I said, and is also expensive. Proof of stake, on the other hand, is more energy efficient, an alternative to proof of work, as validating a block is less expensive and large investments is not really needed in terms of specialized equipment. It can be scalable. It also has very, very high security. And the proof of stake, however, may sometimes be also vulnerable to attacks, and the validators can validate multiple versions of the blockchain without incurring any penalty. So then you need to watch out for that. The consensus mechanisms delegate there are other ones too, as I mentioned earlier. There are those mechanisms are obviously not very famous, but proof of work and proof of stake remain to be the most popular ones. And hope this overview of the consensus mechanisms of blockchain technology is helpful to you. Thank you.